Okay, 7 has got the the trickiest one of all the others. So it's a little interesting. Okay, so the setup on this one is we're going to double the last digit. And, sorry. And at that point, we're going to subtract from the rest of the number. Okay. If the difference is divisible by 7, then the original number is. Okay, so let me start with something simple. Let me just 672. Okay, so the rule says double the last digit. So we have 2 that we're going to double. So 2 times 2 is 4. Then I'm going to, so let me take that, sort of break that up into 2 chunks. Then I'm going to take the other 2 digits, 67 minus 4, get 63. And then I'm going to ask, question, does 7 go into 63? Okay, and the answer is yes, it does. 7 times 9 is 63. So therefore, 7 goes into it. But notice what we can still do, in case we couldn't think of 7 times 9. I can still take that last digit, so I can break that up. 3, so double it, and get 6. And then 6 minus the 6, I get 0, and that works. Okay. Let me get something a little bit bigger that we can play around with. Okay, 875. Okay, so I'm going to split that up, double the 5, so 87 minus 10 is 77. Well, obviously 77 is divisible by 7, so 7 goes into 875. Okay, so I want to do something a little bit bigger that requires this process to be repeated a few times, just so we can kind of see the power of this. 8,806, is that in fact divisible by 7? Well, I'm going to separate out the last digit from the rest. So I went 880 minus 2 times 6, and 880 minus 12 is 868. Okay, still not quite sure if that's divisible, so let me take that. So 86 minus 2 times 8, so minus 16 gives me 70. Yay! Okay, does 70 work? Well, I know 70 is in fact divisible by 7, so I know that 7 is divisible by 8,806 is divisible by 7. Anyway, so you can repeat the double the last digit and subtract from the other process a couple of times if you need to.